Hey, what's going on, guys? This is going to be your test review video, 548.5 in the trapezoid rule. Start with number one here. It says find the indefinite integral. Check the results by differentiation. Right here, we're going to do u substitution. I'm going to start by making u 4x. All right, and then take the derivative of that. So du over dx is going to be 4. And then we rewrite this to have du over 4 equals dx. Now, I'm going to integrate tan of u, du over 4. All right, substitute u for 4x and substitute, I'm sorry, this should be dv. But substitute du over 4 for dv. All right, because this is dv. So let me fix that up real quick. So now we're going to take out this 1/4 because there's nothing to divide. So I'm going to take out the 1/4 like this, and then I have tan of u du. So now when I integrate tangent of u, it gives me natural log of the absolute value of cosine of u plus c. So that's it right there. And again, where did I get that value from? I had to look at my chart. Sorry about that. That's my son's homework right there. I had to look at my chart, tan of u du. Oh, I forgot my negative. This is why you got to have your chart. So there's your negative right there. So negative ln absolute value cosine of u. All right, so this should be a negative right here, which means that is going to be negative. Put the negative out front, so negative 1/4 ln of the absolute value of cosine of u plus c. All right, there we go right there. So for our next video right here, number 2, for this one, I'm going to let u equal x cubed. And the reason I'm going to do that is because I know the derivative of x cubed has an x squared in it. So when I take the derivative of du over dx, that gives me 3x squared, right? See that x squared? I'm going to end up canceling that out in a second. So du over 3x squared equals dx, right? So now I substitute that into the equation. So I have x squared tan of u, because I made x cubed u, and then du over 3x squared, because dx equals du over 3x squared, which we settled, right? So now, looking at this, you see that x squared right here, and that x squared right here is going to cancel out, and I'm left with a 3 down here, so we're going to pull that 1/3 out. All right, du. And now we're going to integrate that, okay? So that gives me 1/3 times negative natural log of cosine of u plus c. All right, and doing this one, I see this should be absolute value, guys. Sorry about that. That should be absolute value. Natural log of absolute value of u plus c. And I see I made a mistake. See how I didn't put u back right here? That should be 4x. I'm going to come back and do that in a second. But there we go right here. There's u. So now I just substitute u back into the equation right here. So it gives us negative 1/3 because of the negative right here. Natural log of the absolute value of the cosine of x cubed plus c. There is our answer right there. Okay. And now let me jump back over here to this example right here. The mistake I made was I did not put in my u back into the equation. My original u was 4x. All right, if you remember, the original u was 4x. So there we go right there, okay? Yep, so let's keep going. All right, this next part here. Okay. All right, I'm going to actually make u this one. And I'm going to tell you why. Because see, 8x to the ninth, 9 times 8 is 72 x to the eighth. So I'm going to actually cancel this out. This is the integral, the derivative of this one. All right. So u is going to be 8x to the ninth plus 4. And so du over dx equals 72x to the eighth. All right. So now du over 72x to the eighth equals dx. So now when I rewrite this, I get u to the ninth because I said this is u times 72x to the eighth du over 72x to the eighth. All right, and then from there we can just cancel this out, 72x to the eighth, and I'm left with the integral of u to the ninth du. And so when I integrate that, you get u to the 10th over 10 plus c, and then I'm just going to plug u back in. So that would be 8x to the ninth plus 4 raised to the power of 10. So over 10 plus c. So there we go right there. The next part here, we have, sorry, I'm having all sorts of technical weird situations. Okay. So this one, I'm going to rewrite this first. So sine of 3x, cosine of 3x to the fourth. All right. So now when I do this, I'm going to make u this internal function right here, cosine of 3x. And du over dx is going to be, here, let me show you. The derivative of cosine is negative sine. All right. So that gives me negative sine of 3x times 3, because you have to take the derivative of the internal function as well. All right. So that gives me du over negative 3 sine of 3x. And again, that 3 came from right here. 3 times negative sine of 3x is negative 3 right here, right? So when I rewrite this, I have sine of 3x times u to the fourth du over negative 3 sine of 3x. All right, and of course, I think you see what happens here is that sine of 3x is going to cancel. So I'm left with this negative 3 right here, which I'm going to bring out a negative 1/3. And now I'm going to integrate, well here, let me rewrite it first, u to the fourth du. So now when I integrate this, you have negative 1/3 u to the fifth divided by 5 plus c. So when we plug back our u into the equation, you're going to have, I'm going to simplify this to negative 1/15. So negative 1 over 15 u to the fifth, or cosine of 3x to the fifth plus c. Okay. Right here, same thing. I'm going to rewrite this one first. So it can be sine of x cubed. Cosine of x dx. And the reason I do that is because now this is the derivative of sine of x. So when I say u equals sine of x and you go du over dx, the derivative of sine of x is going to be cosine of x. All right, and again, we see that on our chart right here. The derivative of sine of x is cosine of x. All right, so du over cosine of x equals dx. And when we write this, we have u cubed I almost made a mistake right there. Cosine of x times du cosine of x. That substitutes for dx. And so now the cosine is going to cancel, and I'm left to integrate u cubed du. Sorry. I said du, but I wrote dx, which gives us x to the fourth over 4 plus c. And now we just plug our u back into it. So you can write it as like 1/4 sine of x, or sine of x over 4 plus c right there. Wait, did I forget something? I did. It should be to the fourth power. To the fourth power. There we go. Alrighty. This one here, cosecant of 6y dy. I'm probably going to let u equal 6y here. So du over dy equals 6. So I have cosecant of u du over 6. Oh, I didn't rewrite this. Sorry. Du over 6 equals dy. All right. So now, 1/6, I bring that out front. Here, let me change colors because that can be confusing. I'm going to bring out 1/6 right here. Cosecant of u du. So now when we integrate this, we get 1/6. And then cosecant, here we go, the trig, cosecant. Oh, wait. Right here, oh. So look at my chart right here. All right, this was the actual chart from your notes. Cosecant of u is ln of cosecant of u minus cotangent u plus c. So I'm going to go cosecant minus cotangent. Sorry. Natural log of cosecant u minus cotangent u plus c, right? So I'm going to just plug that in. Let me separate this so you guys know. And then I just plug in u. So I end up with 1/6 natural log of cosecant of 6y minus cotangent of 6y plus c. Now, right here, find a particular solution of the first derivative of 1/5 x minus 4 and the initial condition of 10, f of 10 equals -30. So what I first need to do is integrate this equation right here. So when I integrate that, that gives me 1/5 x squared divided by 2 minus 4x plus c, which we can definitely simplify to be, I guess, 1/10 x squared minus 4x plus c. And now I'm going to evaluate it where this is my x and this is my y. So I'm going to go 1/10 times 10 squared minus 4 times 10 plus c equals -30. So that's 100 times 1/10. That's 100 divided by 10 is 10. Minus 40 plus c equals -30. 10 minus 40 is -30. So I have -30 plus c equals -30. And then I'm going to add 30 over, so c equals 0. So because c equals 0, I just take this equation, or where I simplified it right here. And the answer is going to be 1/10 x squared minus 4x. C is 0, so that's it right there. All right, or f of x equals that. All right. Now, for each function, approximate the area of the region using 4 subintervals. Draw a sketch. Make approximations using the trapezoidal rule. Then compare with the exact value of the area you find using your calculator. Is this approximate area an over or under estimate? So what we first need to do, I'm gonna find delta x first. And the reason I like to find delta x first is because, again, this is the width of each trapezoid. This is how wide each trapezoid is. So remember, you got to do b minus a over n. All right, so I'm going to do 1 minus 0 over 4, and that's 1/4. So that tells me each trapezoid is going to be 1/4 wide. All right, so now I'm going to graph, this equation, this function right here, -2x plus 3. So I go to my calculator right here. All right, so there's our function right there. And then graph. I'm not joining the skewed, so let me fix it real quick. I'm going to go zoom fit or zoom 0 right there. Fix that. Oh man, let me make sure I'm in the right mode. Alright, so there's our graph right there. Sorry about that. So let's go ahead and look at this. And basically, you got to understand that each one of these is a fourth wide, all right, all the way to 1. So really, I'm just going to draw mine right here. If this is 1, each one is a fourth wide, all right, so 0, 1/4, up. Man, my drawing's off. All right, 1/4, 2/4, 3/4, and then 4/4, which is 1. So there's my sketch right there. All right, so you would just go over to yours and of course sketch that. So there's my graph. Now what I got to do is I need to find what the height of these values are right here. These lines, that line, and that line, and these lines right here. I need to find the height. So what I'm gonna do is I'm gonna go back to my calculator and I'm going to go second graph for the table, and I got 0, 1/4, which is 0.25, or you can do 1/4, and then 1/2, and then 3/4, and then 1, right? So there we go right there. So 3.25 to 1.51. All right. So I'm going to, because of the trapezoid formula, I have to multiply the width by 1/2. So I got 1/2 times 1/4, which is 1/8. So I'm going to do 1/8 times the height. It was 3 plus 2 times, it was 2.5. All right, plus 2 times 2, 1.5. 2, then 2 times 1.5, and then 1 was 1, like that. All right. And so when we do that, so we said 1/8 times, we said 1 times 3 plus 2 times 2.5 plus 2 times 2. Whoa, did not mean to do that. Plus 2 times 2.5. No, 1.5. Sorry about that. Plus 1. Like that. And that gives us 2. All right. 2. So this equals 2. So now I need to do the actual one. The actual area model, which is math 9. Remember that? So I'm going to punch that into my calculator real quick. So I'm going to go math 9 from 0 to 1 of negative 2x plus 3 dx. And we hit enter. It's 2. So in this case, it's not under or above. It is spot on. So this one's spot on. So it's not in the under or over. It's neither. All right. Yeah. So because the actual interval from 0 to 1, negative 2x plus 3 dx equals 2. So they're the same. They're equal. All right. All right. Number 9, same type problem. Let's see here. So again, first I'm going to find delta x first. So I'm going to do 2 minus 1 over, I guess n is the same. N is going to be 4 again because of the directions. So 2 minus 1 is 1, 1 over 4. So 1/4 is delta x. So I'm going to graph this real quick. Square root of x plus 2. S plus 2. Hit graph. Alright, so we got 1/4 from 1 to 2. Alright. So 1/4 to 1 to 2. So we have, let me do a quick sketch. 1, because we want 1 and 2. So if this is 1, then this is 1 and 1/4. So that's 5/4. Here, let me do this. So 5/4. All right, and then plus 1/4 is going to be, whoa. To 3/2. This is 3/2 right here. And then we're going to add 1/4 to that. 7/4. And then you add 1/4 to that is 8/4 or 2, like that. All right. So these are the values, max values: 5/4, 3/2, 7/4. All right, from 1 to here. So, oh, and it was this. All right, so one of those heights. So let me go back to the calculator. All right, so we have 1. Remember, this one starts at 1, and then we said 5/4, and then we said 3/2, and then 7/4, and then 8/4 or 2. So those are values right here. All right. So now what we're going to do is we're going to go back over here. And we're going to do 1/4 times 1/2 is 1/8. So we do 1/8 times the first height was 1.7321 plus 2 times 1.8028 plus 2 times 1.8708 plus 2 times 1.9365 plus 2. All right, so now we need to do this. So we have, when we punch this in, so this one I got 1.869. All right, when I do the exact one, math 9, 1 to 2, the square root of 2 dx. All right, math 9. So we enter on that, and it gives us 1.869 as well, but 8692. And when I punched in the other one, it was 8.690375. So it was actually an under. All right, this one was 1.8693. This one was 0. So this will be technically under. All right, that's under this one. All right, so here, evaluate each definite integral. Again, this is calculator work right here, so I'm actually going to punch these in, and let me make sure you pay attention to how I put this absolute value into my calculator. X right there. And then we're going to evaluate that with respect to x of dx. And then, boom, 8. Okay, we get 8. So this one's 8. And then we're going to do the same thing for these right here. So real quick, I'm going to run through these. All right, and then we're going to do okay. Now for this one, you see how this one has power of 4? So we're going to change the mode of our calculator to radians right here. Now we're going to change this to radians. So when I put this one in, change your mode. Go ahead and change that to radians because it has that pi in it. All right. Now I'm going to press math 9, and then I'm going to punch it in. And as you see, we got 0.75 or 3/4. Alright. Now right here, find the mean value of the function on the given interval, then find all x values that have this value. So what we first need to do, right here is integrate this thing. Well, actually, first I want to find one over b minus a. So it's going to be 1 over 3 minus a negative 3. And then we're going to integrate this 25x squared. 25 minus x squared dx. So that's going to give us 1 over 6, because that's plus, so 3 plus 3 is 6, times this is going to give us 25x minus x cubed over 3. And we're going to evaluate that from negative 3 to 3. So 1/6 times, if I plug in 3 right here, 27, 9. So that's 75 minus 9 is 66, minus negative 75, negative, but plus, so negative 66. So that right there becomes plus 66. So 132 divided by 6 is 22. So that's going to give us 22 right there. For this one, same thing, 1 over b minus a. Let me zoom back in so I have more space to write. 1 over b minus a. So 1 over 1 minus a negative 2. For 1/4 x cubed plus 7 dx. And we integrate that. That's going to be, let's see, 1 over, that's plus, so 1 over 3 times 1/4 x to the 4th over 4 plus 7x, from negative 2 to 1. And so, again, you can let your calculator just do this work for you. If you go right here, y equals, actually, let me simplify this real quick. So I'm going to say 1/3, and then I have 1/16 x to the 4th plus 7x. And I got 1/16 because 4 times 4 is 16 right there. Now that is what I'm going to punch into my calculator. So I'm going to go back to my calculator. Alright, so there you go right there. And then we're going to hit graph. Alright, let's see here real quick. I need negative 2 and 1. And that's going to be negative 13, 7.0625. So if I go 1/3 times 7.0625 minus a negative 13, let's see, 7.0625 plus 13. That's 20.0625. So 1/3 times 20.0625. And that's going to give me 6.6875 right there. Let's keep going. For this one right here, all right, I'm going to rewrite this one a couple times. 1 over b minus a, so 1 over 8. 8 minus 0 is 8. And then we have 5 x to the 1/3 dx. And now when we integrate that, that's 1a times 5x to the 4/3. 1/3 plus 1 is 4/3, all over 4/3. And then we're going to keep flip that. So that's 1/8. 3 times 5 is 15 divided by 4. X to the 4/3 from 0 to 8. So now I just need to evaluate that right here. So I'm going to throw that in the calculator. All right, so 15 over 4x to the 4/3. I'm going to graph that. It looks like a football. The tip of a football. Anyway, go to my table here. 0 to 8. So 0 and 60. All right. So, whoa, didn't mean to do that. Thought I was still on my pen. Anyway, 8 was 60. And minus 0, which is just 1/8, times 60. And that is going to be 7.5. So 7.5. Now, for the last problem of the evening, or my evening, shall I say. Let's see. I'm going to do, here, let's do A, actually, A, and then B, guys, is going to be 7. All right, because it says it right here. It says the first, determine the average concentration for the first 7 hours. All right, so B is 7. So I'm going to do 1 over B minus A. So 1 over 7 minus 0 is 7. All right, I'm going to write that anyway. And then I'm going to actually rewrite this as well. So I'm going to go 150x times 3x squared plus 50 to the negative 2 dx. And now I'm going to use u substitution. 3x squared plus 50 du equals 6x over dx. So du over 6x equals dx. All right. Now let's plug and simplify some of this. So that's 1 over 7 times integration of 150x times u to the negative 2 du over 6x. And now, if you look real quick, you'll see that the x's right here, the x's are going to cancel. And so we'll now have 150 over 6, right? Let me rewrite it for you. And that right there is 25. So I'm going to pull out that 25 real quick. So 25 over 7 u to the negative 2 du. All right, so now when I integrate that, that gives me 25 over 7 times u to the negative 1 divided by negative 1 from 0 to 7, which we can rewrite this. we can rewrite this as 25 over 7. That's a -1. Yeah, that's a -1. So -1 over u, because the u right here needs to go to the bottom to be positive. But we still have that -1 here. 0 to 7. And then I just plug in, I plug in u, so -1 over 3x squared plus 50 from 0 to 7. And then we're going to evaluate this. So I go to my calculator. All right, so there we go. I put it in and then hit graph. There's our graph. So back to our table. And we need 0 and 7. So we have negative. This is our larger, -0.0051 minus -0.02. So back to this, 25 over 7. We have -0.0051 minus -0.02. And then when you do the math on this, I'm just going to do this, 25 over 7 times 0.0251. This right here, remember that's addition, so that's 0.0. Actually, nope, I did that wrong. This is 0.0. Almost made a mistake. Oh shoot, didn't mean to do that either. 0.0149.0. Sorry. 0.0149. That 0 doesn't look like 0. Anyway, man, multiply that by 25 divided by 7, and that's going to give us 0.0532. All right, I think I'm done. Yeah, I'm done. So, I hope this helps.